Hello everyone. Today we will be discussing about another very important topic in chemistry, that is equations. How to write equations, what are the rules for writing an equation, that is a chemical equation, and how to balance it. So today our topic will be chemical equations. Now, the first thing is I'll just write a simple chemical equation and explain it to you. Now, we've already done symbols and valency writing of chemical formulas. So, this is the symbol for magnesium. We all know that. This is the symbol for oxygen, and this is the formula for magnesium oxide. This we have already done. Now, I think you all have studied that O is for oxygen, but here I have written O2. Now, oxygen is always found in the diatomic state. That means two atoms of oxygen always combine together and they form oxygen. So, we do not find oxygen in a single or a monoatomic state. They always two atoms of oxygen combine to form a molecule of oxygen, and we always find oxygen in the diatomic state. That is why we write O2. Now, what information do you get from this chemical equation? Now, magnesium reacts with oxygen to produce magnesium oxide. So, what two things were taken? Magnesium and oxygen. So, your left hand side is the reactants and the other side is the product that is formed. Okay, so left hand side denotes reactants, the right hand side denotes product. So the first information that we get from a chemical equation is the names of the reactants and the names of the products. Okay, now the next thing. Now this single arrow. Now, so the first thing I told you, okay, let me write down the points first. The first thing is the left hand side denotes reactants and the right hand side denotes the products. Now the single arrow. What does this single arrow mean? That means the reaction is irreversible. What does the term irreversible mean? That means once magnesium oxide is formed, we cannot get back the original substance, that is magnesium and oxygen. So, single arrow indicates that the reaction is irreversible. That means once the products are formed, we cannot get back the reactants. It is a chemical change. In a chemical change, we get a new substance. We cannot get back the original substance. So, single arrow means it is irreversible. Now, just see this equation. So, as already stated, this nitrogen and hydrogen are the reactants, and we call this ammonia. Ammonia is a product. So, these are the reactants, this is a product. Now, see here. In the previous equation, it was Mg plus O2 gives out MgO. Only a single arrow, and I told you single arrow indicates irreversible. That means we cannot get back the original substance. Here, double arrow. Now, double arrow indicates that the reaction is reversible. That the reaction is reversible. So if the conditions are reversed, then I can get back the original substance. For example, when we heat water, what happens? It changes into, so this is suppose liquid form, so let's write water. It changes into water vapor when I heat it, isn't it? And now when I remove the heat, what happens? The water vapor changes back to water. So this is also a reversible reaction. So if we can get back the original substance, that type of reaction is called reversible reaction, and it is indicated by using a double arrow. The next one now. The next rule. Now, suppose heat is required. Suppose I take magnesium and oxygen and I have to heat it. Now here in this equation, how will I denote heat? So just above the arrow, I will put a triangle, small delta. This triangle is called delta. So this delta indicates heat. Okay? So number 3. So this is number 4. The fourth rule is, if in a reaction heat is, suppose the reactants has to be heated, then just above the arrow we put a delta sign. Okay? Next. Now in element, if you remember, when we did the chapter Elements, Compounds and Mixtures, I explained two terms, exothermic reaction and endothermic reaction. Exothermic reaction and endothermic reaction. So, exothermic reaction is a reaction in which heat is produced. Heat is produced. And endothermic is heat is absorbed. So, here when heat is either you require heat or heat is absorbed, then an endothermic reaction is indicated this way. But suppose heat is produced. Okay, suppose I give you an example of C6H12 O6 gives out CO2 plus H2O. Here, now heat is being produced, exothermic reaction. So, if heat is utilized or it is an endothermic reaction, the heat sign, that is delta, is written above the arrow. And suppose heat is produced, it is an exothermic reaction, then the delta is written towards the products. Okay, so just remember this difference. Endothermic reaction, or if heat is utilized, delta sign or the heat sign is written above the arrow. And suppose heat is produced, it is an exothermic reaction, the heat sign or the delta sign is written along with the product. So by looking at the simple equation also, you can tell whether it is an exothermic reaction or whether it is an endothermic reaction. The next one now. Now, oxygen is a gas. Hydrogen is a gas. So in the equation, to indicate a gas, we always use an upward arrow. Like this way. Nitrogen is also gas. Hydrogen is also gas. Ammonia is also gas. So to denote whether that particular element or a compound is a gas or not, we use an upward arrow. So upward arrow indicates gas. So wherever there is a gas, you have to put an upward arrow indicating it is a gas. Okay? Then now in certain equations, particular temperature, pressure is required. In that case also, exactly like heat, the temperature pressure, whatever it is. So each equation has a specific temperature. It has to be heated up to a particular temperature or a particular pressure is required. Then those information has to be written above or below the arrow. So everyone, I hope you have understood different rules of writing a chemical equation. Now the most important part is balancing. We have to always balance the equation. Now what does the term balance mean? Now according to the law of conservation of mass, matter, we all know what is matter? Matter can neither be created, that means we can never create matter, nor can it be destroyed. So matter can neither be created nor destroyed, but it can be changed from one form to another. So since matter is neither being created, neither is it being destroyed, that means the number of molecules or the number of atoms of these elements on both the sides, that means the number of elements in the reactants and the number of elements in the product should be the same. That means the mass of the reactants should always be equal to the mass of the products. So let's see how do we balance an equation. So since you all are just starting off, this is the easiest method. Draw a rough of column. Make 3 columns. This will be the left hand side. This will be the right hand side. Okay? And let's start off with the first equation that we have done. The same equation now I have taught you. Upward arrow indicates gas. Now let's find out how many number of elements are there on the left hand side and how many are there on the right hand side. The first one is of magnesium and the next element is oxygen. So magnesium, since nothing is written, means 1. If nothing is written, means 1. So magnesium, left hand side 1, oxygen is 2. Magnesium this side. See, the number has to be written here. Okay, so magnesium here nothing is written, that means it is 1. Oxygen also nothing is written is 1. Now if you see this side, the number of magnesium atoms are same. Here it is 1, here it is also 1. But in case of oxygen, in the left hand side it is 2 and in the right hand side it is 1. So we have to balance it. Both sides the number should be the same. So which side is less? The right hand side, and which is less? Oxygen. Okay, now see, here oxygen and magnesium form a compound. So whenever I add numbers, I cannot add numbers in between because it is a compound. So I have to write the number in front of this entire compound. So since oxygen is 2 this side and it is 1 this side, I will put 2 here. Now I recommend that you do the balancing of equation with pencil. Okay. So now see, magnesium, since here is 1, here is also 1. 1, 2 is 2. It means magnesium here becomes 2. Oxygen, 1, 2 is 2. Oxygen also becomes 2. Now see, oxygen is balanced, but magnesium is not balanced. It is 1 this side and 2 this side. So we go to the left hand side and I put 2 here. And it is 1 here, so 1, 2 is 2. So 2, 2, 2, 2. Now this equation is balanced. Okay, let's do another one. Okay, carbon plus oxygen gives carbon monoxide. Okay, so CO, carbon nothing is written means 1, oxygen 2, here nothing is written, then it's 1, oxygen is not balanced. Which side is less? The right hand side. What is less? Oxygen is less. But this is a compound. I cannot write 2 in the middle, so I have to write it in the front. Carbon becomes 1 2s are, sorry, this is the right hand side, 2. Oxygen, I told you nothing means 1, we have to multiply. 1 2s are 2. Now oxygen is balanced but carbon is not balanced. Come here, 1 2s are 2. So 2 2 2 2, now it is balanced. One more. Delta sign means heat is required. Upward arrow means it is a gas. Now here see, there are 3 elements. Potassium, chlorine and oxygen. Potassium 1, chlorine 1, oxygen is 3. This side potassium is 1, chlorine is 1, oxygen is 2. Again, what is not balanced? Oxygen. And it is less towards the right hand side because this is 3 and 2 here. Now see, oxygen is separate here. So I can write a number here because there's a plus sign here. There's a plus sign here, means this and this is separate. So I can put a number here. Now it is 3 here, 2 here. If I put 3 here, as I told you, we have to multiply. 2 3s are 6. Now, right hand side is 6, but left hand side is 3. So I'll go to the left hand side. Now I have to put 6. So 3, how much are 6? 2. So I can't put 2 here because this whole thing is a compound. So I have to put it in the front. 3 2s are 6. But see, there is K, there is Cl. So K becomes 1 2s are 2. Cl also becomes 1 2s are 2. Now it is not balanced towards the right hand side. What is not balanced? K and Cl. If I put 2 here, 1 2s are 2. Cl also 1 2s are 2. Let's see, 2 2 2 2 6 6. Now it is balanced. I hope you all understood balancing of equations. We'll be continuing with balancing of equations in my next video. Thank you everyone.